All right, we're going to continue learning about systems and solving systems. This time we're going to solve systems by substitution. Before we used graphing, wherever they intersected is a solution. Now we're going to do substitution. So what we're going to do is we're going to solve one of the equations for one of the variables. It doesn't matter which variable. Then we're going to substitute this one from here into the other equation. And once we do that, we're going to solve for the variable. Once we find one variable, we plug it in the other. So there's a bunch of substitutions. So it says write your answer as an ordered pair. If x and y are not used, put your ordered pair in alphabetical order. So we're going to start with these two equations. So the goal is you want to get a variable by itself. So if we can isolate, if you notice, x is isolated. So since x is isolated, whatever x equals, we're going to look at x into the other equation, and we're going to substitute that into here. Because this is saying x is equal or the same as y minus 4. So wherever we see x in the other equation, we're going to substitute this in instead. So remember, whenever you do substitution, always put parentheses around it. And then now that I have y minus 4 instead of x, I'm going to distribute the 2. And then I've got 2y minus 8. Don't forget to bring down the rest of the equation. And now we're going to combine like terms and then bring down the negative 8. So now we need to move this to the other side by doing the opposite. That cancels out. I'm left with 3y equals 27. And then again, we want y by itself, so you need to divide both sides by 3. That simplifies to give you 1. And now we have y equals 9. All right, so we're almost done. Now we know what one of the variables is. We're going to plug it in to either equation. It doesn't matter which one, but I usually try to pick the easier equation. So now wherever I see y, I'm going to substitute in 9 instead. And now 9 minus 4 is 5. So we have an x, we have a y, and remember solution is an ordered pair, x, y. So we would do 5, 9. So if we were to graph these, they would intersect at the point 5, 9. All right, I want you to go ahead and try that equation. Now we're going to do this one. Now this one is a little different because we don't have, here we already had a variable by itself. But here we don't have a variable by itself, so we have to get a variable by itself. So what I'm going to do, it doesn't matter which equation you pick, but the first equation, it's a little bit easier to get y by itself because it doesn't have a coefficient. So I'm going to take this equation, I'm going to move it down here, and I'm going to go 3x plus y equals 3. Well, I want to get y by itself, so I'm going to subtract 3x from both sides. That cancels, so now I'm left with y equals negative 3x plus 3. So now y is all by itself. Now that we have y by itself, so remember we took the first equation, so we're going to substitute this into the second equation. So instead of wherever we see y, we're going to substitute this in instead. So I'm taking my other equation and I'm writing whatever was originally there, but as soon as I see y, I'm doing parentheses and substituting that in there. And then don't forget, equals 1. All right, so now go ahead, distribute. And then combine like terms. And you could write x or 1x, same thing. Bring the rest down. And now we want to get x by itself. So you're going to have to move this over here by making it negative 6. And then you'll get x equals negative 5. So I've got an x, I've got a y, and you write it as an ordered pair. So I want you to go ahead and try this one. I'm going to give you a hint. This x is already by itself, so it would be really easy to do this equation first by adding 2y. So once you get x equals 2y plus 6, then you can substitute this in for here. All right, so I want you to go ahead and try this. And if you do, or if you did this one correctly, oops, I never gave you the answer for this one, sorry. If you did the top one correctly, you should have gotten -6, -16. And if you do the second one correctly, you should get -2, -4. All right, so now let's look at this last one. So the goal is you want to get a variable by itself first. Okay, well there we go. We've got a variable already by itself. So now we're going to take, since this is by itself, whatever that is, wherever you see it in the other equation, that's what you're going to substitute in. So we're substituting it back in. So I'm going to write 3x, I'm going to write my minus, and remember wherever I see y, I'm writing this instead. Put parentheses around it, and then don't forget to bring down the rest. All right, now remember this is technically a -1. So we're going to distribute that -1 to 3x and get -3x. -1 to 2, we'll get -2. Bring the rest down. And combine your like terms. Oh, wait a minute. If you notice here, 3x minus 3x equals 0. That cancels out. So I don't have any variables. But let's look at what I do have. So when that cancels out, I'm left with -2 equals -2. Well, is that true? Yes, it is true. So if that's true, what it means is infinitely many solutions. Now, very important, make sure you're writing this down. So if your variables cancel out and you're left with a true statement, so if it's true, it's infinitely many solutions. If we would have gotten something like, I'll just use this as an example, false would be like 5 equals -3. So this is a false statement, so that would be no solution. So this one would be like 2 equals 2. All right, so what you're going to do is you're going to go through, you're going to try this equation, and then I am going to give you the hint, it is going to be no solution. So when you're solving this, make sure you're showing the work of what it should be. All right, oh, that was a short set of notes, but again, make sure you go through, solve your equations, and the goal is get a variable isolated first, take whatever it equals and substitute it into the other equation.